Today we will discuss about Theorem 7.1 ASA Congruence Rule. According to this rule, two triangles are congruent if two angles and the included side of one triangle are equal to angles and the included side of the other triangle. If we want to understand ASA congruency rule, so first we will take two triangles, and so the proof of this theorem is we are given two triangles ABC and DEF, in which suppose angle B of triangle ABC is equal to angle E of triangle DEF, and angle C of triangle ABC is equal to angle F of triangle DEF. So, and BC side from triangle ABC and EF side from triangle DEF both are equal. So we need to prove that triangle ABC is congruent triangle DEF. Actually, this sign represents the congruency of two triangles. Congruency of two triangles. So this is basically a sign to represent the congruency between two triangles. For proving the congruence of two triangles, see that these cases arises. So let's understand all these cases. Case number 1. Let AB is equal to DE in figure 7.12. This is these two figures. This is a triangle ABC and this is a triangle DEF. So AB is equal to DE. This side is equal to this side. Okay, we assume both sides are equal, and angle B and angle E, this angle equal to angle this, it is given in the statement, and side BC is equal to EF. This side is equal to this side, this is also given, and the triangle ABC congruent triangle DEF by SAS congruency rule. So we have already discussed SAS rule. So by SAS rule, these two triangles are equal. It means two sides of two triangle and included angle between these two sides are equal, so we can say that this triangle and this triangle are congruent. Now, case number 2. Let, if possible, AB is greater than DE. So we can take a point P on AB such that PB is equal to DE. PB, this side, is equal to DE, this side. Now consider triangle PBC, this triangle, and triangle DEF, this whole triangle. According to these two diagrams, observe that triangle PBC and triangle DEF, PB is equal to DE. Now PB, this side, is equal to DE by construction, and angle B is equal to angle E. This angle is equal to this angle. It is given, or we can say that both are the corresponding angle, and BC and EF, these two sides also equal. It is also given, so we can conclude that triangle PBC congruent triangle DEF by the SAS axioms for congruency. So by SAS property we can also prove this triangle congruent to this triangle by the property of SAS. SAS means side, angle and side. So by this congruency rule we can say that both two triangles are congruent. So now let us move forward, and since the triangle are congruent, their corresponding part will be equal. So by the CPCT, corresponding part of a congruent triangle, so angle PBC is equal to angle DEF. Suppose this is a triangle PBC and other is, this is a triangle DEF. So angle PCB, this angle is equal to DFE, this angle, because this triangle and this triangle both are congruent. So after congruency, the corresponding part, or corresponding parts mean corresponding angles and corresponding sides will be equal. So that's why this triangle and this triangle both will be equal. But we are given that angle ACB is equal to DFE. This is also given, and angle ACB is equal to angle PCB is equal to angle PCB. Let's take the above diagram so we can understand easily. ACB, this angle, and PCB, this angle, both angles are equal. So if we see here, the angle C, both are the same. So is this possible? This is possible only if point P means point coincide with A. It means if point P coincide with point A, then it will be possible. It means this point coincide with this point. Coincide means, suppose this is a point and this is another point. This point overlap to this point and merge in this point. So this point and this point will coincide and will make a single point. So that is a procedure for the coincide. If both will be coincide, then this will be the possibility. So BA is equal to ED. BA, this one, BA is equal to ED. ED, this is a point E. So BA is equal to ED. So we can say triangle ABC congruent triangle DEF. So this triangle also congruent to this triangle by SAS axiom rule or congruency rule. Let's understand the case number 3. Case number 3, if AB less than DE, we can choose the point M on the side DE such that ME is equal to AB, and repeating the argument is given the case number 2, we can conclude AB is equal to DF. And so triangle ABC congruent triangle DEF. Suppose now in two triangles, two pairs of angles and one pair of corresponding side are equal, but the side is not included between the corresponding equal pairs of angles. Are the triangle still congruent? Let's understand. Suppose this is a triangle ABC and this is a triangle PQR. So suppose AB angle A is equal to angle P, angle B is equal to angle Q. So could it be possible the side AC equal to PR? So we can say that triangle this and this both are congruent. Because of that, side AC and side PR are not included in these two triangles. Because side AB and side PQ both are included in these two triangles. This side and this side included in the angles, but this side is not included with this angle, and this side also not included with this angle. So could it be possible these two triangles are congruent? Let's understand. We will observe that they are congruent. Can you reason about and why? You know that the sum of the three angles of a triangle is 180 degree. Angle sum property. So if two pairs of angles are equal, the third pair is also equal to 180 minus sum of two angles. Okay, so two triangles are congruent if any two pair of angles and one pair of corresponding sides are equal. Then we may call it as angle side congruency rule. Now let us perform the following activity. Draw triangle with the angles 40 degree, 50 degree and 90 degree. How many such triangles can you draw? So these are the measurement of the angles 40 degree, 50 degree and 90 degree. In fact, you can draw as many triangles as you want with different length of sides. So see figure 7.14. This is a 90 degree. This angle also 90 degree. This is also 90 degree. This is also 90 degree. And let us assume this angle will be 40 degree. This will be 50 degree. Maybe this will be 50 and this will be 40. So this is a 40 degree. This is a 40 degree. This will be the 50 degree, and this is a 50 degree. And this angle will be 40 degree and this angle will be 50 degree. So these are four figures here, so we can understand the measurement of angle, and we can arrange like in this, like that, and in this pattern. Now observe that the triangles may or may not be congruent to each other. So equality of three angles is not sufficient for congruency of a triangle. Therefore, for congruency of a triangle out of three equal parts, one has to be the side. This statement says that the equality of three angles, equality of three angle is not necessary, is not required for the congruency of a triangle. Three angle. This rule is not exist for the congruency of a triangle. For congruency of triangle, this will not exist for the congruency. Two angle, possibility is two angle and one side, or two side and one angle. So three angle will not be considered in the congruence of a triangle rule. So basically this is a representation of angle side angle congruency with two triangle. Now let us understand the example number 3. Line segment AB is parallel to another line segment CD. Line segment, this is AB, and this is another line segment CD. O is the midpoint of AD. This is O point. It is a midpoint of AD. Midpoint mean this is a midpoint. Midpoint mean OD is equal to OA. This point divide line segment AD in two equal parts. That is the meaning of the midpoint of O. So that triangle AOB congruent triangle DOC. And second proof is O is also the midpoint of AB. So let us understand the solution of this particular problem. Problem number 1. Consider triangle AOB and DOC. This triangle and this one. ABO, angle ABO, this angle, and angle DCO, this angle. Alternate interior angle. alternate angle as AB parallel to CD and BC is the transversal line. This line and this line both are parallel and making Z. So this angle and this angle will be equal. Because of that, these two angles are alternate interior angle. And after that, angle AOB and angle DOC, this angle and this angle, both angle are vertically opposite angle. So these two angles, this is a pair of angle are equal, this is a pair of angle are equal. So we have already equal two angles, two pair of angle. This represent one A and this relation represent another A. So if we want to prove these two triangle congruent, so one requirement is left, sides. So here OA is equal to OD. OA, this side OA is equal to OD, which is given in the question. Because of that, O is a midpoint of AD, so OA is equal to AD. It is given in the question. So this relation represent S. So side angle. Okay. By this rule, we can write like that: triangle AOB and triangle DOC are congruent by the rule AAS, or angle side angle rule of congruency. Now the second proof is O is the midpoint of BC. So let us understand, because of that, this triangle and this triangle now are congruent by angle side rule congruency. So we can write like that: the corresponding part of both triangle will be equal. So the OB is equal to OC. OB, this side is equal to this side. So these two sides will be equal by CPCT rules. CPCT means congruent part of corresponding triangle. So due to this relation, we can write like that: O is the midpoint of BC, because it also divides BC into equal part, OB and OC. If OB and OC are equal, it means these are equal and equally divided BC. So O will be the midpoint of BC. So that is a proof of this question. How to prove these type of question with the help of the congruency.